So, welcome back, everybody. I hope you all had a chance to grab a cup of coffee, to get a little caffeine in the system for the next part of the day. But it will have some stimulations that will also help to keep you awake, I'm hoping. And the first one that we will receive is one from Professor Roberto Calandra from the Technical University in Dresden here. He originally comes from Italy, had formerly done some academic work for Meta in the US, or for Facebook at the time and Meta now. And he's also the founder of the Robotic Lab in Menlo Park, which is today a part of embodied AI. Now he's a professor at the Technical University in Dresden, and the faculty that he just started a couple of months ago sounds really, really interesting. It's explainable artificial intelligence, and I think what the world needs right now is some explanations about AI. So I'm looking forward to the presentation about Digitizing Touch, which will basically touch the topics of machine learning, tactile sensors, robotics. Roberto, the stage is all yours.
Thank you. All right. Thank you very much for inviting me here. Today I'll be talking about a topic that might come new for most of you, which is touch. And in particularly, I'll be talking about digitizing touch. And I think that there will be I hope that there will be many interesting points of contact with some of the work that you do. So if we think about touch, touch is the first sense. It's the oldest and deepest sense into our brain. You can be born blind, you can be born deaf, but nobody is born without sense of touch. And touch is very much assumed in our everyday life, while barely even realizing it. Every time that you're grasping an object, what you're doing is that you're sensing object properties of what you're touching. You are balancing forces. And if you wake up at night and you look for your cell phone, in most cases you will not need to use vision. You will just reach out with your hand and find your way purely based on touch. And just to give you an example of some of the experiments that Ronald Johansson did in the past, this is an example of people asked to be doing very simple tasks like lighting a match, and then they would anesthetize their sense of touch. And suddenly, things that for us are completely normal, that we do every day hundreds of times, suddenly become extremely difficult, because we heavily rely on our tactile sensing and our perception of touch into our motor control skills every day. Now, what I'm going to basically propose today, what I'm going to try to argue today, is the fact that we are in a very particular moment in history, and that in the next few years, what we will see is a significant breakthrough in the digitalization of touch. And the typical pitch that we give to people, including former workers, that is to look at what happened in the 1800s, when for the first time we had telephones at scale. We had cheap hardware that everybody can buy, that everybody can use it. And what happened is that we now have significant business opportunities and the capability of basically recording audio, transferring over long distances, and playing it back. And this not only creates, as I mentioned, this business opportunity, but also creates new field of computational science dedicated to making sense of audio, of processing audios, and nowadays, through the use of machine learning, we can talk to our phone, and our phone can understand what we're talking about. Yeah? And a similar process happened in the 90s with the introduction of digital sensors for vision. The capability of being able to take pictures and digitize these pictures and send them over long distances and playing it back, display them on our phone. And nowadays, this, of course, also has significant business impact, significant opportunities, both from a scientific point of view on computer vision, being able to understand and make sense of vision, but also everyday uses. We all have hundreds, of digital cameras and digital microphones in everyday life everywhere. And what I'm going to suggest and want you to think about is the fact that we are at the verge, for the first time in history, to have cheap, reliable hardware for digitizing touch. And in the same way that this has created significant impact for for audio and video, I will argue that this digitalization of touch will allow the creation of a new field of computational science dedicated to making sense of touch, but will also open significant business opportunities to be able to digitize, record touch, transfer it over long distances, and playing it back. And just to talk a little bit of some of our contributions, this is Digit. This is the first scalable, mass-producible, high-resolution, low-cost tactile sensors that we designed and open-sourced 2 years ago at Facebook. This sensor was not designed to be the best sensors that we can build nowadays, but it was designed to be able to democratize touch by providing everybody the opportunity to build one, 3D print one at home, or buying it for very, very cheap. And Digit allow you basically to read the geometry of the object that you're touching with a resolution, with a precision that is comparable to the one that we have into our artificial skin. Here are examples, for example, of a piece of Velcro and the corresponding image that you would get out of the sensor, where you can go down to about 50 micron and see the individual teeth of the Velcro. This really opened the possibility of being able to digitize sensations and geometries and forces that you can sense with this sensor. And most importantly, if we compare to the previous state of the art of commercial sensors, Digit has a resolution which is 3 orders of magnitude larger. It's 1,000 times more high resolution, while being 1,000 times cheaper. So now we can build these devices for $15. And this really opened the market for these sensors to be very soon into every houses or connected with our phones and digitizing touch. And of course, we are not only interested in building hardware that is cheap, but we are also interested in making use of machine learning to really understand and make sense of this raw data that we get from our sensors to, for example, being able to recognize what type of material we are touching, or if you are touching a particular, like an avocado, to know if the avocado is ripe or is not ripe yet. Really understanding what are the physical properties of the world that we are touching. And this is also an open source work, which was aimed to basically democratize machine learning and provide easy-to-use models for everybody out there. Now, some of the key applications that we are generally interested when we want to digitize touch include things like prosthesis. If we could really digitize touch and play it back onto people that lost their limbs, this would have a great beneficial impact onto our society and the peoples that were sort of unfortunate from these points of view. And not only fingers, but you can imagine that we can digitize skin, we can digitize feet. So every surface that we can think of, we have ways of digitizing touch there. Another application is obviously the metaverse. If we really have to have digital world, being able to tactile, physically sensing the world, be able to digitize objects from our real world easily into our digital world while preserving the capabilities, the mechanical properties, the same feeling sensations that we have in the real world could be extremely important and valuable. E-commerce. If you could have these sensors in everyday house, you could be touching a sweater and say, hey, Alexa, buy me a sweater with the same properties, with the same particular thread from Scotland, or something that is as soft as this. And finally, for the things that I'm personally more interested, robotics. In our lab, we do a lot of robotics, and being able to provide robots with the sense of touch is going to be crucial to give them the same dexterity that humans have for manipulating the environment and interacting with the world and humans in a safe manner. Specifically for the metaverse, as you can imagine, my previous employer, Facebook, had significant interest in the application of the metaverse. And if you think about touch, touch is indeed the most deeply emotional and deeply social sense that we have. Even nowadays, even after COVID, shaking the hand of somebody allows us to create a social relationship that just being able to say hello doesn't. And the same is true if you are thinking about your family. Hugging your grandmother, physically touching her, allow you to interact and create a connections which is qualitatively different from just being there, seeing them through a screen. And of course, the main question in this case is, how can we digitize touch? How can we sense it? How can we process it, make sense of it, send it over long distances, and then play it back using haptic devices? And also, how can we calibrate all of these devices so that they are truthful and feel real? And of course, in all of this, our work focuses on these first two aspects, really on the digitalization of touch and in the processing and potentially transferring of compact representations. Just to give an example of some work that we did a few years ago, we built a setup where people were able to, through AR/VR headset, were able to look through the eyes of a robot, were able to control the robot by moving and having a machine learning algorithm track their limbs, and then a haptic device where they could basically get feedback from tactile sensors on the fingertip of the robot. And this enabled them to very easily control complex machine like this robot, which was a full humanoid robot with over 40 different joints, to operate them in a very natural and intuitive way with little to no training, and to be able to solve tasks like grasping objects, handing over objects. And you can think that potential applications of, for example, being able to teleoperate medical devices from one continent to the other to do specific surgeries, or even just for tourism. Recently, there was the very famous prize in robotics where people wanted to just be able to visit other countries remotely and feel it real. Now, of course, there are also applications in hardcore robotics, as I was mentioning. So, for example, here we had some work on being able to manipulate marbles, glass marbles, which is an extremely fine manipulation task, which is very difficult for robots, because you need to really be able to sense the forces between the marbles and the fingers, because if you apply too much force, you will squeeze them out. If you don't apply enough, gravity will win, and the marble will fall on the ground. And of course, in all of this, we use heavily machine learning to be able to process the very rich and extremely computationally intensive type of data that we get out of these sensors. So sort of to conclude my talk, what I really want you to get out of this is the fact that touch is a key sensor modality, both in humans and in robots, although we barely realize it through our everyday experience. But in practice, so far has been very hard to really use touch, digitize touch, and over the last few years, we have been working very hard to build an ecosystem that integrates vertically all the way from hardware to processing to then control and using robots. And this really enables us for the first time to perceive, understand, and interact through touch in a way that has not been possible before. And what I'm going to sort of argue is that I believe that we are on the verge of a digital revolution where, for the first time, we will be able to digitize touch at scale in everyday life with sensors that are cheap, reliable, and with a resolution, with a precision that is equivalent or superior of what we have as humans in our skin. And for you here today, I think that there is a proposition that this will be an interesting business potentially for telecommunications. These type of devices generate huge amount of data that needs to be processed, needs to be transferred over long distances, and will need to be played back. And in the same way that we have cell phones that can digitize video and audio, I will argue that in 10 years, all our phones will have devices that can digitize touch in the same way, and we will have business activities that will make use of this touch for a diverse set of purposes and interests. Thank you very much, and I'm happy to take questions.
Thank you very much, Roberto. These were fascinating insights on what is about to come. So do we have any questions in the audience about that? You had your cup of coffee? Yeah, there's a question over there. Just wait for the mic, please.
Thank you. It's very, very important, very interesting. Do you have experience with sensations like warm, temperatures? How you can create such not only especially wind, wind and this sensations on the.
Yes, this is a very good question. So human skin is extremely interesting because it's actually made of many different types of mechanoreceptors and receptors in general that provides us information from geometry, forces, temperature. It provides us information about also vibrations. And the sensors that I've presented you here today only capture some of these aspects, namely forces, geometries. However, we do have prototypes of the next second and third generation of this type of sensors that are capable of capturing the full spectrum of what human skin can capture. And in some applications, being able to sense, for example, temperature or being able to sense vibration is in some cases very important because they can provide important cues about object properties.
Thank you, Roberto.
We've seen this experiment where somebody with a special something over to somebody else with such an automated robotic hand. And how much can we delay between what he sees and what he feels in such an experiment? Is there any limit?
Sorry, can you repeat the question? I'm not sure I understand.
The delay between what he feels with touch and what he sees during such an experiment.
Yes. So delay, in the moment when we want to really, the humans have these things that is called body schema. That we feel our body as it's our body. And in the moment when we want to use avatars that are remote, delay is very important. The traditional numbers that people give in the literature is that if you have a delay which is higher than 200 milliseconds, you will have 0 alignment of body schema. And basically, the smaller is the delay, the better people will feel that they sort of belong and that they are physically there. In some of these experiments I show with our, that particular humanoid robot, the delays were in the order of about 100 milliseconds. But it becomes very critical to have fast communication networks, a lot of bandwidth, because you need to be able to transfer a lot of different sensor modalities through, basically across the globe very, very fast. So it's crucial.
So this is my keyword. Well played, Bernd. Of course, we need the networks to communicate these kinds of information very fast. And I understand this is one of the key reasons why latency plays such an important role in the development of 5G and 6G. Roberto, thank you very much for your presentation.
Thank you again.
And the networks and their quality is obviously the next thing we would like